You know, building a modern user interface today, it sometimes feels genuinely absurd.
Oh, completely. It
Yeah.
really does.
It's like, say you decide you want to build a simple, wooden birdhouse for your backyard. So you buy some wood, and suddenly somebody rolls up to your house, hands you a 500-page manual, and just parks a massive industrial crane right on your lawn.
Right, yeah. It's an immense amount of overhead for what is fundamentally a very simple goal. I mean,
Yeah.
you just want the birds to have a place to sit. But the industry has largely normalized using that crane for absolutely everything.
Yeah, exactly. And that's our mission for today. We are looking at a guide on a tool that promises a shortcut to dynamic, interactive web pages, but without burying you under a mountain of complex code, massive libraries, or, a labyrinth of build tools.
Which is a relief for a lot of people.
Seriously. The tool is called Alpine.js. So, okay, let's unpack this. Because if we look at the reality of modern web development, users absolutely demand interactivity. I mean, they expect modals to glide open, data to refresh seamlessly, and UI states to toggle without those clunky full-page reloads.
Right, the standards are super high now.
Exactly. But the default reflex for a lot of development teams is to immediately reach for the heavyweights, like React, Angular, or Vue.
Yeah, and those are the cranes from your analogy. They're incredibly robust, comprehensive solutions designed to engineer highly complex state-driven applications. But the source text we're looking at really highlights the cost of that power. You don't just write a file and open it in a browser anymore.
Nope, those days are gone.
Right. You had to compile it, bundle it, manage this brittle web of dependencies, and configure your Webpack or Vite environment before you've even written a single line of actual interface logic.
Which just feels like a massive barrier if you just need, say, a drop-down menu to work. So the guide positions Alpine.js as the minimalist alternative. It draws inspiration from Vue and React, but it strips away all the build step bloat.
Okay.
And the footprint in the author sites is just wild. When zipped, Alpine.js is about 10 kilobytes.
Which is practically microscopic in today's web.
I mean, that is smaller than a single low-resolution placeholder image on most sites. It's smaller than the text file of a short story. So I have to push back immediately here. With a footprint that tiny, it feels like we're trying to frame a house with a pocket knife.
Yeah.
Is this just a toy for basic aesthetic tweaks, or can it actually handle legitimate UI requirements?
I totally get that. I completely understand the skepticism. It sounds like it couldn't possibly carry any real weight at 10 kilobytes.
Yeah.
But its power doesn't come from a massive library of pre-built components. Its power actually lies in how it fundamentally alters the relationship between your markup and your behavior. It just skips those heavy abstractions entirely.
Okay, well, if it skips the abstractions and doesn't require a build process, what is it actually doing under the hood? Like, how do you get React-like interactivity in 10 kilobytes?
It basically comes down to two core mechanics. There's a declarative syntax and proxy-based reactive data binding. Let's look at the syntax first. So in imperative programming, which is how most vanilla JavaScript is written, you write a separate script that reaches into the HTML, finds an element, and gives it a step-by-step list of instructions.
Okay, so that's like giving a chef hyper-specific instructions, like walk to the fridge, grab one egg, crack it, whisk 5 times, turn the oven to 350.
Yes, exactly. Very step-by-step. Alpine, on the other hand, uses a declarative approach.
Which is more like handing the chef a photo and just saying, I want a chocolate cake. You declare the end state.
Right. Perfect analogy. To make that concrete for web dev, think about how you build a standard collapsible accordion menu. Imperatively, you write an HTML div, give it an ID, then write a totally separate JS file with an event listener, a function to toggle a CSS class, and logic to check the current state.
Right, it's a lot of bouncing around.
It is. But with Alpine, you just add special attributes directly to the HTML tags. You might write xdata equals open as false on the parent container, and then on the button itself, you just add @click equals open becomes not open.
Wow, okay.
And then on the content you want to hide, you just drop xshow equals open.
So you are explicitly telling the HTML how to behave right where it lives. But wait, hold on. Doesn't putting JavaScript logic directly inside HTML tags make the codebase a total nightmare to maintain?
Wait.
Because, I mean, we spent the last 2 decades preaching the whole separation of concerns thing. Keep your structure, your styles, and your behavior in completely different files. This sounds like throwing all your clean clothes and dirty shoes into the exact same drawer just to save a few seconds.
That's the classic pushback, yeah. But what's fascinating here is how Alpine, along with other modern tools like Tailwind CSS, actively challenges that old dogma. The text argues that for the specific scale of interactions Alpine targets keeping the behavior co-located with the markup actually reduces the mental friction.
Huh. I guess I can see how bouncing between files creates cognitive load. Like, if you are debugging a broken button, hunting through a 500-line separate JavaScript file to find the one specific event listener tied to that button's class name is pretty tedious.
It's a game of hide and seek. With Alpine's locational behavior, you look at the HTML button, and the logic dictating its state is right there staring at you. The separation of concerns ideology sort of assumed that separating technologies like HTML over here, JS over there, was the exact same thing as separating features. But a button and its click behavior are the same feature. They really belong together.
Okay, yeah, I buy the argument for co-location. But let's talk about the second mechanic you mentioned, reactive data binding. Because the ability to just write xshow equals open and have the browser instantly know what to do implies a whole lot of heavy lifting behind the scenes.
Oh, definitely. And this is where the 10 kilobytes really flexes. In traditional JavaScript, updating the screen requires manual DOM manipulation. You have to write code that literally traverses the document, finds the specific node, deletes the old text, and inserts the new text. It is highly manual, and if your application state gets out of sync with your UI, you get bugs. Lots of them.
Right, it's like constantly erasing and rewriting data on a chalkboard. It leaves smudges, it's slow, and it's super easy to accidentally erase the wrong thing. And React solves this with the virtual DOM, right? It creates complete secondary copy of your interface in memory, calculates the differences, and then updates the real screen.
Exactly.
Which is incredibly powerful, but that engine is heavy.
Very heavy. Alpine completely bypasses the virtual DOM. Instead, it uses modern browser APIs natively, specifically JavaScript proxies.
Okay, how does that work?
So when you define your data using that XData attribute, Alpine wraps that data in a proxy and essentially puts a tripwire on your variables. The moment a piece of data changes, say, a user clicks a button that changes a counter from 1 to 2, the proxy intercepts the change instantly.
Oh.
Yeah, and Alpine knows exactly which HTML elements are bound to that specific piece of data, and it only updates those exact elements.
So there's no massive reconciliation algorithm comparing two entire virtual trees in the background. It just directly surgically updates the one DOM node that needs it.
Exactly. And it does all of this natively in the browser. You don't have to write a single query selector or manual update function. The UI simply reacts to the data state.
That is incredibly slick. Okay, so we have locational behavior, declarative syntax, and proxy-based reactivity, all without a single build step. Which leads me to the practical application here. Theory is great and all, but where are development teams actually deploying this out in the real world?
The guide outlines several primary scenarios. The most obvious one is replacing massive libraries for simple interactions. Things like drop-downs, pop-up modals, loop banners, slide-out sidebars.
Basically the functional scaffolding of almost every site on the internet.
Right. Historically, developers might have loaded the entirety of jQuery just to get a basic slide toggle effect. Or they pull in a massive UI library. Alpine handles all of these UI patterns natively. It even has an X-transition directive that automatically handles CSS animations for elements entering or leaving the page.
Oh, nice.
Yeah, which usually takes dozens of lines of custom JavaScript to orchestrate cleanly.
I can imagine. And if it's this lightweight, I'm guessing this is a massive advantage in the design phase too, right? For prototyping. Because you wouldn't have to spin up a whole React environment just to see if a complex tabbed navigation thins right to the end user.
Oh, it is a phenomenal prototyping tool. A designer can jump into a raw HTML file or a code pen, drop in the Alpine script tag, and just immediately start wiring up functional, state-driven prototypes. It is. You can test interactions, validate UX decisions, and iterate rapidly without ever touching a command line interface or configuring a bundler.
Now here's where it gets really interesting for me though. The guide discusses applying Alpine to legacy platforms. Massive monoliths. We're talking WordPress, Shopify, older Laravel or Django applications. These are systems that are heavily reliant on server-side rendering, just spitting out static HTML. And the source pairs this with the philosophy of progressive enhancement.
Right. Yes. Progressive enhancement is essentially the strategy of building a really solid core experience that works for everyone and then layering on advanced functionality for browsers that can handle it.
The way I sort of conceptualize progressive enhancement is like adding a clip-on electric motor to a standard bicycle. Like if you attach the motor, you get to zoom up the hills and it's this premium modern experience. But if the battery dies or if the user's browser totally strips the JavaScript away for some reason, you still have a bicycle. The pedals still work. The core functionality doesn't just break.
That analogy perfectly captures why Alpine thrives in those legacy CMS environments. Think about a developer who is tasked with modernizing a 5-year-old WordPress site. The client comes in and wants a dynamic live filtering search bar or an interactive shopping cart drawer that slides out without reloading the page.
Right. And if you wanted to do that with React, you'd basically have to decouple the entire architecture. You'd have to turn WordPress into a headless CMS, build out REST APIs, and rewrite the entire front end completely from scratch. You're tearing the house down to the studs just to remodel the kitchen.
Which is a multi-month project with huge budget implications. Clients don't love that.
No, they definitely don't.
But with Alpine, zero extensive refactoring is needed. You literally just drop a single script tag into the head of your legacy HTML template. Yeah. That's it. You can sprinkle Alpine attributes directly onto the server-rendered HTML that WordPress or Shopify is already outputting.
So it just peacefully coexists with the back-end routing.
Exactly. It doesn't demand total control over your project the way the heavier frameworks do.
It just quietly augments the existing structure. It intercepts the user's click, updates the UI, maybe sends a quick background fetch request to the server, and updates the DOM all while the underlying monolithic backend just continues functioning exactly as it always has.
It's such a pragmatic solution to a very common industry problem.
Yeah.
You get that snappy, modern user experience without the crushing technical debt of a full architectural rewrite.
Okay, so we've established that it's a 10 kilobyte powerhouse. It handles reactivity natively via proxies, it speeds up prototyping, and it drops right into monolithic legacy projects with a single script tag. I gotta say, it sounds suspiciously like a magic bullet, which means we really have to map the boundaries here. If it's this frictionless, why isn't every tech company on Earth ripping out their heavy frameworks and running exclusively on Alpine.js? Like, where does this architecture actually buckle?
That's a fair question, and the guide is very upfront about the limitations. Alpine is purpose-built for a specific scale of complexity. The first major wall you will hit is the ecosystem.
Right, because when you buy into React or Vue, you aren't just getting the framework. You are getting a massive global economy of open source solutions.
Exactly. If you need a highly complex data table with multi-column sorting, pagination, and drag-and-drop row reordering, someone has already built a heavily tested React package for it. You install it, configure it, and you move on. Alpine just doesn't have that sprawling, decades-old ecosystem.
So if you need advanced, highly specialized UI components, you are basically going to be building them from scratch in Alpine, which kind of negates the time you saved by skipping the build step in the first place.
Exactly. And that leads directly to the second, probably most definitive limitation. Alpine is fundamentally not designed for heavy single-page applications.
Which makes sense, because an SPA isn't just toggling UI states, it's practically an operating system running in the browser window. Think about an application like Gmail or a complex financial dashboard. You have hundreds of interconnected components. You have complex global state, where a change in the sidebar needs to instantly update a data visualization 3 layers deep in the main window.
Right, the data flow is immense.
Yeah.
Furthermore, you are managing intricate client-side routing. As the user clicks around, the URL in the browser changes, and entirely new views are rendered, but the page never actually performs a hard reload. Alpine is not a router.
Yeah.
While it does have a feature called Alpine.store for managing global state across different components, it is simply not built to orchestrate the complex multi-view data juggling required by a massive web app.
So to adapt our earlier analogy, Alpine is like a perfectly engineered multi-tool. It is unmatched for tightening a loose screw, fixing a hinge, or adding interactivity to a server-rendered page. But you wouldn't use a multi-tool to frame a 3-story house. You absolutely need the crane for that.
The problem is that developers often misdiagnose their projects. They assume they are building a 3-story house, so they bring in the crane on day one, when really they just needed a multi-tool.
But this raises an important question about project evolution, though. What happens to the developer who accurately diagnoses their project at the start? Say they start small, they use Alpine because it's lightweight and perfect for the job, but 2 years later, the business pivots. The user base explodes, the feature requests pile up, and suddenly that simple server-rendered site actually needs to become a full-blown SPA. The fear of framework lock-in is a massive driver of technical debt. If you start with Alpine, are you trapped when the project outgrows it?
Framework lock-in is a very real threat, definitely. But Alpine offers a really unique advantage here. Because it has no complex build process to untangle and no proprietary state management system woven deeply into your back-end logic, ripping it out is a surprisingly painless process.
So it doesn't sink its claws into the underlying architecture.
Not at all. Your structure is still just standard HTML. Your backend is untouched. If you reach the point where you truly need to migrate to React or Angular, you are essentially just deleting the Alpine script tag and stripping out the xdata and xshow attributes from your markup. You are left with clean, semantic HTML ready to be ingested by the new framework. It is vastly easier than trying to migrate from one heavy SPA framework to another conflicting SPA framework. It is a highly low-risk starting point.
Wow. So what does this all mean? Let's bring this all together for you. We started by looking at the sheer exhaustion of modern web development. The cranes, the massive configuration manuals, the overwhelming complexity required just to get a simple interface to react to a user. Alpine emerges from this guide as the ultimate pragmatic middle ground.
It's all about aggressively right-sizing your tools. It offers a delightfully gentle learning curve that leverages the HTML and JavaScript knowledge you probably already have. It loads with blistering speed, bypasses the heavy virtual DOM in favor of native browser APIs, and allows you to seamlessly sprinkle modern interactivity over legacy systems without breaking them.
Yeah, so whether you are a lead developer prepping for an architecture meeting and trying to advocate for a leaner tech stack, a designer wanting to rapidly prototype a state-driven UI without touching a terminal, or you just inherited a massive, aging WordPress monolith that needs a snappy new search filter, Alpine gives you an immediate, powerful capability without all that bloat. It respects the developer's time, and it heavily respects the user's bandwidth.
It proves that you don't always need a heavy abstraction layer to build something that feels modern and responsive. Sometimes, working closer to the metal, or in this case closer to the HTML, is the more elegant solution.
It really is. But I want to leave you with a final provocative thought to mull over before our next deep dive. We've spent this time discussing how Alpine relies on declarative attributes, baking the behavior directly into the markup. And we see this trend acceleration across the industry right now, not just with behavior, but with styling tools like Tailwind 2. As we pack more and more logic, state management, and styling instructions directly into our tags, are we heading toward a paradigm where HTML completely ceases to be a simple structural document? Are we watching HTML slowly evolve into a fully fledged, unified programming language in its own right, blurring the line entirely between the structure of the house and the electricity running through its walls? Something for you to ponder. Until next time, thanks for joining us on this deep dive.